There, let's continue talking about that retirement portfolio simulation. No mini exercise associated with this video, but we'll also connect the work we did over the last couple videos to the fifth homework assignment. So just to recap, right, we built a 20-year retirement savings simulation assuming the same annual deposit of $15,000 a year and normally distributed returns, right? And the main benefit of this over just a point estimate, right, the basic time value of money problem that we did, an annuity problem, is that we get a range of possible outcomes. So let's connect this to how you'll approach the fifth assignment. Right, here's the problem we did, and some of the things that were pretty highly simplified about it were the same deposit every year. We assumed no growth in deposits over time, which isn't realistic. Hopefully, as your salary grows, you'll save more for retirement, at least in dollar terms. So let's think about some of the portfolio simulation things that you might want to, you should probably incorporate into your analysis in assignment 5. So I'm hoping you can think carefully about these things and try to build reasonable assumptions, at least for the first couple, right? So in terms of time horizon, how long will you work? How long will you save? In the assignment, I've got it up here. We're assuming that we're just going to invest in the overall stock market, right? The S&P 500. But yeah, you're welcome to relax that assumption if you want. If you want to sort of shift away to less risky assets over time, you can model how that works. An important component of this model is rebalancing. So there's the assumption is that, well, we can talk about this later in the course, maybe if we have time, but how our portfolio gets rebalanced away from like risky assets to less risky assets can affect the results quite a bit. Here's a big one that I'm hoping you'll incorporate into your assignment: how deposits change over time, like we discussed. And the more realistic you can be as you build this assignment, I think the more valuable it'll be for you. So another thing to think about as you're building a simulation is, I always try to emphasize, our model is only as good as the assumptions that underlie it. So we assumed normally distributed returns with this mean and standard deviation, right? In real life, investment returns are not normally distributed, especially stock returns. You'll see that most stock returns have a negative skew, meaning like the returns that are below the mean tend to be much further from the mean. And we're seeing that right now with the overall market, right? The bad returns tend to be really bad. And incorporating that kind of asymmetry into the distribution, that non-normality, is challenging. But let's plan to discuss it actually when we talk about value at risk. We'll go over some points on how to address non-normal returns. But for now, I focus on building this assignment, maybe with this retirement simulation as a basis, but obviously, hopefully you'll have a different investment horizon, right? And your deposits will grow over time. The assumptions about risk and return will hopefully come from the data that goes along with the assignment. You can choose to use all this data or some of this data. It's up to you to make that assumption. And I'm curious to see what you come up with. So thanks for tuning in to this video. This pretty much wraps up simulation. There's a lot more we could do on it. And let's talk briefly about the extensions actually. Right? We'll look at value at risk and use simulation and value at risk. And then in terms of the bond portfolio management, things we've discussed already, we could model bond defaults. I'm sure you could imagine how simulated default probabilities could help us enrich like a default adjusted expected return model. And then also if we could simulate changes in interest rates and how that would affect our bond portfolio in terms of immunization, that's another extension. So lots of other ways we can go with this. If you're interested in talking about simulation in any of these areas, let me know. But for now, let's leave it at that. Thanks for tuning in.